Okay, hi everybody. I'm Karen Dillon. I'm the director of the Arlington Youth Health and Safety Coalition, and I'm so happy to see so many of you here. I'm happy to see families and some young people here because I think this is a really important conversation we need to have. It's a community issue, and we're focusing on marijuana and youth tonight. I want to emphasize that. So any other topics about that, really, this is a place we're going to focus on youth use and prevention, hopefully, too. I'm going to look at my notes so I don't forget anything. How many of you know about the coalition? Raise your hand, please. Okay, so not all of you. So I'll tell you a little bit about us. We're a community coalition. We're entering our 9th year of a grant cycle that we receive from the federal government. We're focused on reducing substance use among youth in Arlington. We do educational outreach to parents, to schools, to community members. We meet once a month and we have open meetings. You're all welcome to come to a meeting whenever you want. We have a student branch of advisors who speak to us about issues of concern to them. We have a parent group of advisors that do the same. So there's lots of room for community involvement. And I always like to see new people get involved. I think it's a nice way to get a silent majority of people together. I think a lot of people have the sense that, especially if you're a parent, that you're in a minority if you don't support or encourage youth experimentation, when in fact you are the majority, and you'll find that when you connect with other parents. So it's a great way to have that kind of strength in joining. What else was I going to say? So marijuana use and legalization is a controversial topic regionally and nationally. I am reading articles constantly, and I can barely keep up. I have some stats written on these paper because they change constantly. Tonight we're going to be talking about the effects of recreational marijuana on the teen brain and body. I want you to also please keep in mind that the majority of students at both Arlington High School and Ottoson Middle School do not consume marijuana in any form. So what we'll speak about is that the majority don't use. Sometimes parents ask my opinion. They ask me what's worse, because we know that alcohol is very detrimental. They say, what's worse, alcohol or marijuana? And I want to say, before we even start, anything that hinders youth development, whether it's emotional, physical, or physiological, is harmful. So there is not a better or worse. They're both harmful. We want to talk about allowing people to have their brain develop, and that doesn't finish happening until they're 25 or 26 years old now. And so we're lucky to have an expert in the area of the brain, and I would like to introduce Dr. Marisa Silveri. And I've got my script here, so let me see if I can read it. I'm using my, they used to call them bifocals, my progressives. So I'll have to see how I can read with these. So Dr. Silveri is a behavioral scientist. She's an associate professor of psychiatry at Harvard Medical School, and she's an adjunct assistant professor of psychiatry at the Boston University School of Medicine. Dr. Silveri is the director of the Neurodevelopmental Library on Addictions and Mental Health in the Brain Imaging Center at McLean Hospital. Dr. Silveri uses MRI to study teen and emerging adult brain maturation with a focus on healthy brain development and identification of neurobiological effects of drug and alcohol use and identification of risk factors for later substance abuse and psychiatric illness. Dr. Silveri's work is funded by the National Institute on Alcohol Abuse and Alcoholism, which is a branch of the NIH, and the John Alden Mental Insight Foundation. John Alden and Mental Insight Foundations. Dr. Silveri has received numerous awards and honors and has authored over 60 peer-reviewed scientific publications. She co-edited a special issue on the adolescent brain, which was published in the Neuroscience and Biobehavioral Reviews in 2016. You got a lot of long words in this. Dr. Silveri is heavily engaged in outreach, speaking extensively on the topic of the adolescent brain development and the effects of alcohol and drug use on brain function within her local communities, nationally, including on behalf of the nonprofit organization, the Community of Concern, and internationally. Dr. Silveri received a Bachelor of Science degree in Biology and Psychology from Union College in 1995 and a master's degree in 1998 and a PhD in 2000 in Behavioral Neuroscience from the State University of New York at Binghamton. Dr. Silveri has been an Arlington resident since 2007 and is a proud Bishop Elementary School parent. And so I'm going to welcome her, but I just want to let you know how the evening is going to unfold. So Dr. Silveri is going to give a presentation. I've seen it. It's engaging, it's interesting, and fun. Then we're going to have a panel discussion, and I'll introduce our panel. We're going to have 5 esteemed panelists who are going to be ready to answer questions. I'm going to walk around with a mic, and you raise your hand, and if you have a question, we will have a discussion. And I hope young people and young adults and adults will feel free to ask questions, okay? So without further ado, Dr. Silveri.
Thank you. Yes, you did. Thank you. Well, this is the first time I've ever gone to a talk, and I could say that I actually walked here. My talk on Wednesdays in East Bridgewater, so I don't think I'll be able to do the same. So, good evening, everyone. Thank you so much for the invitation to present. I've been doing this work for a couple of decades now. And so part of what we know is that we all have brains and we need to take care of them. Part of what we do in our lab is really to identify what makes the period of adolescence so important and why we really have to take extra effort to protect that process. It's not to say any other stage of life is not important, but what we know and what we're learning is really quite profound in terms of what's going on inside of that brain. So the one thing that we always like to think about is the fact that there's something that every single person in this audience has in common. We've all been teenagers. For better or for worse, we have all experienced that period of life. And we can really think about adolescence as this great time, right? It's like skydiving. It's exhilarating. There's lots of opportunities. It's wonderful. Maybe. I'm talking about from the kids' perspective. So we also know that's not the whole story. We also know that adolescence is really a drastic roller coaster ride. So this whole host of emotions that are coming online so quickly. One moment you're up, the next minute you're down. Sometimes it happens day to day, month to month, hour to hour. And so that's a tricky part of the ride to navigate as you're making your way through adolescence. And of course, I would be absolutely remiss if I did not mention the influence of peers. Nobody wants to be the odd duck out. Do I have the right phone? Am I going to the right party? Do I have the right jeans? Now, of course, we're interested in if you have the right genes, but from a very different perspective. But the idea is that all of these aspects of being a teenager really converge, right? And so we're interested in what kind of underlies that whole process neurobiologically, but we know that adolescence has a very important reason that it occurs. So we know that part of being a teenager means that you have to seek out new experiences. You have to be a novelty seeker. You have to get out of the nest, right? So you can't go from being dependent on your caretakers to being independent unless there's something in your biology that pushes you to seek out new things. One of the things that comes along with seeking out new things are risks. And so we are partially wired to be risk takers because that's part of the process. But the whole goal of adolescence really is being pushed out of the nest, getting new experiences, and ultimately being able to make good decisions. And that's the whole name of the game, because the role of adolescence is to become independent, is to leave the nest, to be able to do things by yourself. You know, when I talk to all sorts of audiences, and sometimes it's an audience of 1,000 teenagers, which arguably may be one of my most intimidating audiences. I also talk to a lot of parents, and you know, we have this shared desire. Everybody wants to make it, and everybody wants to be independent. If you ask kids why they want to be independent, it's because you want your freedom, right? You want to move on to the next exciting part. If you ask parents why you want your kids to be independent, I mean, parents want their kids to be financially independent and kind of be on their own, and they want their house back and all of these things. So all of these things together are really what fuels this idea. And we are not the first people in the world to wonder what happens neurobiologically to the teenage brain. We've known that the brain develops forever. We've known that you have to get from here to there, and there has to be some biology that underlies that. And so what's interesting is if you kind of look, this is just a graph of people that are doing research in this area. So if you do a search for adolescence and brain, you see that there are thousands. So as of last year, there were over 6,000 papers published on the topic of adolescent and brain. That's a lot of people really focusing in neuroscience on the development of the teenage brain. And so you really wonder, well, why? Why the focus? Why now? And it's really a two-part answer. One is that we have the technology to be able to do that, and we'll talk about that in a moment. But the other important part is that what do we know happens during adolescence? Yes, brain development happens during adolescence, but we also know that this is a time when people, in their novelty-seeking or risk-taking, start to experiment or initiate drug and alcohol use. We also know this is the age period where people or kids really start to experience symptoms of depression or anxiety. And so if you think about all the work that the brain has to be doing to get you not only through adolescence, but through hopefully a very long lifespan, all of the things that are coming online overlap with the initiation of substances, with the onset of symptoms that really are related to mental health. So, if you do a search of adolescence, whoa, and there's the whole talk. Have a good night. There we go. So if you do a search for adolescence in psychiatry, the same idea. There's been such an increasing surge in kids who report being anxious, being depressed. Why is that? There's a lot of competition, there's a lot of stress, there's a lot of information all the time. And so what we want to do is we want to understand this process. And so, what's trailing behind a little bit is adolescence and substance use, but all of this figures in together. And the way, as I mentioned, that we do that is really by looking under the hood of the brain by using imaging. Now, there are a lot of national studies going on. There's a study across the nation looking at the onset of first alcohol use. There's a study that started about a year ago that's actually imaging the brains of 10,000 kids in following them over the course of 10 years. And so the idea here is that what information can we glean from looking at kids? And I think maybe 5 years, 10 years, who knows? Kids will go to their well visit, and maybe there's a tabletop MRI machine, and they can measure something about the brain that might actually give us some useful information. We're probably a far way away from that. But one of the things I have learned in doing all this work is not just what happens neurobiologically, but I've also learned that imaging and what you can see in the brain really resonates with kids. It makes a difference. You see a brain light up or not light up, that actually means something. And so that's the work we've been doing. So we use MRI, magnetic resonance imaging, an entirely non-invasive brain technique. Now, most of you have people in the audience had an MRI before? So you probably know it by that wonderful sound it makes. Dut, 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 dut. Ugh, what is that awful sound? Could they just have one that's a quieter version? So that sound is essentially tuning into the molecules in your brain. And as we tune into those molecules, it produces these pictures. And so it's got the best resolution. It tells us the most about your anatomy. It tells you about the function. It tells you about your chemistry, all in one trip into the MRI scanner. And so that's really what's put us on the map in terms of what we know about the development of the brain. Now, as I said, we've known for a long time. Obviously, people develop. They get smarter. We're interested in the process. We want to know what that looks like. And if we kind of boil it down to adolescence and what makes it so unique, there are essentially two really important processes. The first one, and we're really largely talking about the second decade of life. So when you hear people talk about brain development during adolescence, we're talking about two major things. One is that the first thing to occur is that all those neurons, so you're born with billions of neurons, more than you will ever have in your entire lifetime. And slowly, through the process of exposure and being in the environment and your genetics and all of these things working in harmony, we slowly, have all these neurons that we're going to reshape. And so one of the things that happens is we take all the neurons, so this is a picture of a brain cell or a neuron, this is the cell body of the neuron, these are all the connections to neighboring neurons, this is how they talk to each other, and one of the most dramatic things that happens throughout life, from the time you're born up until you're a teenager, but more dramatically in that second decade of life is something called myelination. What that means is it takes all the connections between neighboring neurons and it wraps it with insulation, right? So if you wrap a copper wire with insulation, you send the message from point A to point B significantly faster, more efficiently. Now brace yourself, I'm a neuroscientist, I make really bad jokes. This is how you get better cell service. Yes, awful. But it has made you have a change of state for a moment, and I've brought you back. I brought your attention back. That was intentional. So that's one part of the story. So, the other thing that's important to know is that when you're born, your brain increases dramatically in size. It increases until you're around age 5 or 6, and then your brain gets no bigger for the rest of your life. Now, that probably sounds surprising because if you think about 5 or 6-year-olds compared to, say, 10-year-olds or 20-year-olds or, 80-year-olds, you think, well, if their brain doesn't get bigger, yet they get much smarter, This is what's happening. This is the reorganization. But we're adding all of this myelination. And so by conservation of matter, if your brain gets no bigger for the rest of your life, but you've added all this connection, at the same time, we have to then take something away. And so the other part of the dramatic process that really happens very rapidly during adolescence is a pruning away or a removal of neurons that you don't need. As I alluded to, you're born with billions of neurons that slowly, through time, get weeded out. And that's really important because we're born with redundancy. That's the great news. We could do a lot of things to our brain and we could still be okay. We can also lose some neurons and we could still function. Or we can, experience a stroke, or we can have a seizure, or something can happen, and then slowly you can have that reconnection. So another part of your brain can actually take over. In the context of understanding adolescent brain development, we've added all this myelination, so now your neurons talk to each other really well. The other part of the story is pruning, and the pruning is removing the neurons that just aren't efficient, that you don't need. And so what we're effectively doing is we're keeping the best of the best, and we're making them really good communicators. And so when I talk to kids, this is kind of like thinking about having best friends. This is not Facebook acquaintances. This is not people who you just happen through their lives in a split second. But this is really those good connections you make, and that's where you get the most efficiency. And I think one of the goals of parenting is really being able to have good communication between parent and teen. So you can think about this neurobiology in a way that's what sets the system up for efficiency. And so the best way to inform this process is to help to ensure that we have a healthy brain development. And so, if you kind of look at this, so this is an example of a brain scan as if someone were looking straight ahead at you. So what you see here is, you have all the brain cells themselves. That's what's referred to as the gray matter. You can see it kind of around the outside, and it's gray in color. We also have all the white matter, so the myelination. Remember, we wrapped all those connections between them, and you can kind of see that. You can see it a little bit better in this cartoon. And so if you remember, your first kind of mini summary of the evening is that during adolescence, we prune, we myelinate. The goal is to get a very efficient brain. And you can actually, you don't have to be a radiologist, you don't even have to be a neuroscientist to be able to tell that picture looks really different than that picture. Now again, this process starts early in life from the time you're born. But what we know is that this pruning and myelinating happens the most rapidly during the second decade of life. Now, that's not to say that things don't happen beyond the second decade of life. Surely they do, but the most important tracks are really being laid at this time. And so if you think about it, what's amazing about the brain is we've known many things about how the brain works and doesn't work long before brain imaging came along. So we studied people who had a stroke, or who had a tumor or had died, and we studied their brains after the fact, or we've looked in animal models. We've done all sorts of things. And what's amazing is that imaging and the tools that neuroscientists use have really confirmed largely what we've known for a long time. But the difference is that we can use this non-invasive technology to have a window into the living, breathing human brain that's repeatable. There are no harmful effects to having an MRI. And so while we've been able to map, this is a picture of the brain as if someone were looking in that direction, we've been able to map and confirm that everything we thought the brain did actually does what we thought. But the last part of the brain to come online is the frontal lobe. You've probably heard people talk about the frontal lobe. What we see when we look at the functions of the frontal lobe are things like attention, working memory, abstract thought, cognitive control, so how well can you control what you're doing, and ultimately decision making. Now, like I said, there's a lot of the brain that's coming online and pruning and myelinating. It just so happens that it happens the most dramatically in the second decade of life, and it happens the most dramatically in the frontal lobe. So it's the frontal lobe, there's this phrase in science that phylogeny recapitulates ontogeny. What that essentially means is that evolutionarily, if you look at animals lower than humans, the last part of their brain to develop to go from animal to human was the frontal lobe. It also happens in humans that the last part of the brain to come online is the frontal lobe. So because it's the last part, it requires a lot of energy and a lot of resources. It's the first part to come online. It's also one of the first parts to go. And so, what we know is that these are the functions of the brain. Now, it's not to say the rest of the brain is not important. So kids always want to know, is it true that you only ever use 10% of your brain? That is an absolute myth. We use all of our brain all the time. It is a fantastic symphony of how the brain works together almost seamlessly. We don't even think about it. All the things that you're thinking right now, you're thinking about the talk and that resonates, or what's my grocery list, or I have an assignment tomorrow. All of these things are occurring simultaneously. And that is how we experience what we know to be existence. And so, million-dollar question, when is the brain adult? Well, as I said, there are a lot of people asking this question, both nationally, internationally, in my lab. And so the answer is that we think about reaching neurobiological adulthood, as Karen alluded to, really does not conclude until the early 20s. Now, 20 is not 20, so everybody is an individual, that's a good thing, but we also know that the course in the path for everybody is a little bit different. It's different for girls versus boys, it's different for people of different backgrounds, and so that's an important thing to keep in mind, that, we are drawing conclusions from average populations, but we know that there are exceptions to the rule. But by and large, we see that these are the general patterns. And so again, neurobiologically, we reach adulthood in the mid-20s. That means, conventionally, we used to think that by the time you got to be 18, went off to college, did whatever you were going to do, or took a job, we used to think that our brain was adult. We now know that has changed. We know that even by the time there was a study done up at Dartmouth, and they studied college freshmen in the fall semester, they studied them again in the spring semester, bearing anything that they may have done to themselves or not, what they actually found were significant structural changes in the brain that occurred. So you go off to college, your brain is wired for learning and memory and paying attention and risk-taking and novelty-seeking and all of those things, and it really continues to occur. And so, I think the important message here is, how do we take care of our brains at any age? So do we focus on the kids? Because when you see children that are, infants, or they're toddlers, or they're in elementary school, we know that they're dependent on us. You see adolescents, and you're very, very independent, and your independence grows every day. But the question is, how do we maintain that? So one of the things that's remarkable is we're in Boston. We are in a hotbed of medical intervention. And collectively, across the world, we have done so many great things to help us live longer. You can replace your knee, a kidney, valves in your heart. One place that we have not been successful is, how do we keep the brain young? How do we learn something about how to take care of our brains so that you have a brain that lasts your entire lifespan? And one of the things that we think is that adolescence might be part of the secret. If we can find a way to help encourage kids to live healthy lives, to take care of their brains now, perhaps that might be one of the best ways to encourage efficiency through the lifespan. So one of the ways that we study this in our lab, and just to pause for one quick second, you're probably thinking, wait, I came here for a talk on marijuana. Why are you talking about the teenage brain? Because I want you to really understand what's at stake. Because there are a whole lot of things we do to ourselves that are probably not healthy. Did you eat a cheeseburger for lunch? Did you sleep for 2 hours last night? Did you not take a vitamin? There are a whole host of things that we could do. But it's important to understand during the teenage period why this is a unique time in life. And so I want you to have that framework behind you. One of the ways that we do this is we use something called this is a very standard go, no, go test. This is like the computerized version of Simon Says Do This. Right? So you're laying in the scanner and you have to press a button every time you see all of these shapes, but when you see this shape, you don't press the button. It sounds pretty easy. Simon says do this. Simon says do this. Do this. Well, guess what that requires? If you have a window into the brain, one of the things you know is that it actually takes significantly more effort for your brain to inhibit doing something than to actually do something. Oh, you're telling me to just hold my hand down and not do anything actually requires more effort? That's true. And so one of the things we know, and what this shows you, this is how much more of the adult brain lights up when you're inhibiting compared to when teens are doing this task, and they have to hold back. So one little quick insider tip about looking at these functional MRI images is that more activation, more lighting up is not always better. It is entirely dependent on the task. What we want is efficiency. You only ever want to use the minimal amount of brain you need to do to get the job done. And so one of the things we know is if we actually did this experiment and you tested the kids, they would go significantly faster. But if you measure the adults, they're significantly more accurate. So it means that kids are really good at things and they can do them very fast. And one of the goals of adolescence, as your neurons talk to each other better, as we get rid of the inefficient neurons, is that now you have this ability to improve your accuracy. This is the speed versus accuracy trade-off. And that is a huge hallmark of adolescence. Now, I'd like to invite you to be part of an experiment. I'm not recording. Well, they're recording me, not you. So please participate. What I want you to do, this is an example of something that we do while people are laying in the MRI scanner. So what I want you to do as quickly as you can, I just want you to name the color of the blocks that are on the screen. Please do this out loud. To give you a little hint in case the resolution's off, it's red, green, and blue. Okay? Is everybody ready? Audience participation. You didn't read that in the footnotes, did you? Okay, ready? Are you ready? Yes. Ready, good. Go. Excellent. Nobody said there'd be a test. Next part of the experiment, as quickly as you can, I just want you to read the words on the screen. Is everybody ready? Yes. Go. Fabulous. Next part of the experiment, as quickly as you can, I want you to name the color of the ink that the words are written in. And I'm sorry. Everybody ready? Go. So if you're wondering again who invited me, that's Karen right up in the front row, and Ivy suggested me. In all seriousness, so I just exposed you to something called the Stroop Test. Take 1 second to read this, right? What does this say? Most people can read words even when the letters are mixed. The brain is excellent at language and reading. You've probably gotten this text or email or something before, and you're like, why can I read this gibberish? Why did I proofread that email 1,000 times and I sent it and I misspelled the first word? That's because language is incredibly automatic. So once we learn to read, now you learn how to name colors long before you learn to read. Once you learn to actually read, all your brain wants to do is read. Even if it's incorrectly written, it fills in the blanks for you. This is such an automatic tendency that what I did was I actually conflicted your brains. I'm sorry about that. But essentially, you completed your first frontal lobe exercise of the evening. And so what does that really mean? We know that the brain, again, has to hold back to be able to actually hold back the want and need to read. You may have found yourself going, red, green. You know what you want to say, you can't stop yourself from doing it. And so this is the frontal lobe working. This is the exact part of the brain that comes online last, and again, this gets better with age. And if you have a window into the brain, you can see, now, again, you use all of your brain, but what we're selecting here is once you subtract out what you do for every part of the task, what's left are very unique parts of the frontal lobe, anterior cingulate cortex and the dorsolateral prefrontal cortex. These are the most efficient ways that you get the best accuracy on this. And so lo and behold, what happens? As you get older, you activate more of this part of the brain. Now again, more is not always better. We're looking for what's the most efficient. And probably not surprising, in 1 year's time, in the life of a teenager, their activation in their brain performing this, holding back that want and need to read, changes significantly. And so that's important to know that, it's not 5 years, it's not 10 years, it's 1 year, it's 6 months. Things can change that quickly, and that's one of the things that, some of these imaging techniques give us is the ability to look at the same kids over and over again. And so, what's the whole purpose of being here this evening is to think about marijuana in particular. And so what happens when kids are faced with tough choices? Now, here's a very benign example. What should I do after class? You have a math test tomorrow. Well, there's a whole host of things that I'm sure that kids could come up to do in the face of the bell ringing. And I often age myself by saying the bell rings because some kids are like, we don't have bells. Like, well, how do you know when class is over? But let's just say, for example, the bell rings and there's a math test tomorrow, and the first thought is, I'm going to hang out with my friends. Oh, but what about that math test tomorrow? If you think it out for a second, maybe your frontal lobe steps in and says, hey, wait a minute, you have a test. You should probably study for that. And so interestingly, if you go down either of these paths, which, let's face it, there are about 1,000 arrows that could come off of this scenario other than studying for the test, right? So there are a lot of things that kids are faced with. There are a lot of choices to be made all the time. And sometimes too much choice is actually not a good thing. And so what happens is that we know that different behaviors are going to give you different outcomes. Maybe you don't do as well if you fail the test and if you get an A on the test. But if we think about what this quick response is for, well, why would you choose to hang out with your friends when you know you had a math test? And so anyone ever, any of the kids in the audience or any of the parents in the audience, have you ever heard or received the phrase, what were you thinking? Anyone, show of hands? Have you said this to yourself? Of course we have. And so we want to understand. So people ask me what I do for a living. I say, I study the neurobiology of what were you thinking? because everybody wants to know, oh, what was I thinking? How did I not hindsight? And so the idea here is that there's a part of the brain that is wired to not have to think. So there's a very primitive structure in the brain, the amygdala, that's in place for our survival, right? So we have this part of the brain, the frontal cortex, that's wiring, doing its thing. It's going to help us make good decisions. It's going to give us logic and abstract thinking, and we can think about consequences. Then there's, on the other continuum, the other part of the brain, the amygdala, the emotional part of the brain that serves one purpose: to help us survive. And so it's very keyed in to things in the environment that are threatening to us. So one example would be something like fear. So if you see someone who's got a fearful face, what we know is that in kids, your amygdala lights up, and it stays pretty constant. It comes online very early in life, so we have this alarm system already in place, and then it doesn't really change over time. Oh, but what changes is how the amygdala works with the frontal lobe, for the frontal lobe to step in and say, hey, wait a minute, there's no danger here. Let me help you make a better decision. And so one of the things that we're studying is not only how that frontal lobe sculpts, but how well it puts the brakes onto, less thought out decisions. And so, we also showed people pictures of food. And what's kind of dramatic about this is that, we show people high caloric foods, low caloric foods, food-related items, non-food-related items. And what happens when kids look at pictures of food is that what you see is that the amygdala lights up like crazy. So it doesn't have to be cheeseburgers. It could be a salad. It could be anything. But if you're hungry, your amygdala lights up because, like, hey, that's food. I'm hungry. I need it. Go get it. So you can see that clearly. If you look in the adult brain, you see the same thing. Here, this little splotch here is the amygdala lighting up. But look at what you have here that you don't have in the teenage brain. Why is this important? It's important because we're all looking at the same thing. All of you in the audience are looking at these pictures, and your brains are lighting up very differently. And so when we ask the question to kids, what were you thinking? And they look at you and say, and you ask them, do you know the right answer? Kids are very intelligent. All of you that are youth in the audience, you are highly intelligent. But even adults experience this themselves. Well, then why did you do it? I don't know. Well, that's the amygdala. And so, I often say, now for the teens in the audience, you cannot use that as an excuse. Next time, what were you thinking? Oh, immature frontal lobe. It's a very appealing argument. But if you know enough to say that, then you actually can't use that as a reason. And so the whole point here is that the role of people who are adults, people who are teachers, people who are in the community to help guide through this, navigating this period of adolescence, it's important. We kind of have to be the rails. We have to help be the frontal lobes until those frontal lobes come online. And guess what? What do you think one of the most important things is for good ability to have cognitive control or hold back those wrong answers? Anybody in the audience sleep deprived this evening? By show of hands, anybody feel like you're sleep deprived? Yeah, most people are sleep deprived. If I had an audience of people doing the Stroop task, that's what you did with the colors, that were sleep deprived, and the other half were not sleep deprived, the people who are sleep deprived would actually perform that task as if they were intoxicated. That is how dramatic loss of sleep can be on the frontal lobe, because the frontal lobe requires a lot of energy and a lot of resources, and if you don't have them, you don't do as well. Most people are sleep deprived. I went to a talk last week by the director of the National Institute on Drug Abuse, Nora Volkow, and she explained sleep deprivation as one of the most important factors. And for kids, it's really, really important because your brain's trying to myelinate and prune. If there's any one place to put an emphasis, sleep is really an important process because it helps you consolidate what you've learned and what you remember. But anybody ever missed trash day? Yeah, that's annoying, isn't it? Because now you have all of this trash. One of the thoughts about sleep is that that's how you clean out all the toxins. So when you're stressed and you're tired and your brain accumulates all these compounds that aren't supposed to be there, when you sleep, that process of sleep cleans all those things out. So next time your kids aren't getting enough sleep, think about missing trash day, because it's kind of the idea. All of these things put a drain on the brain. And if you think about when kids or even adults use substances, when is it? Usually at night. And so substances interfere with sleep, so you're getting even worse sleep. So again, a place to kind of really focus. And you are now resident experts in neuroscience, you know that the frontal lobe is developing. It's predominantly happening in the frontal lobe, inhibitory control. These brain developmental changes help to improve your cognitive control, so your ability to know right from wrong or make better decisions or have abstract thought. And these changes are ongoing as teens initiate alcohol and marijuana use. And so, as I said before, what does this really have to do with marijuana use? Well, not surprisingly, a system that is undergoing such rapid changes. Now, for eons and eons, the adolescent brain has developed. We've all gotten here, adults. Our kids will get there. But we have a choice about how we can help to facilitate this process in a healthy and efficient way. And so I don't have to tell you, it's not surprising, and this is pretty much everywhere, is that there's been a dramatic increase in how many kids are using marijuana today. Even over the last, decade, there's been a doubling in the percentage of kids that use. Now, one of the important points to make is that I'm here as a neuroscientist. I'm not here to give my opinion, pro, anti-marijuana. I'm not here to talk about anything other than explaining that the process of brain development is precious and we need to protect it. And so the fact that it's increasing kind of reflects a couple things. One is that, there's really a mixed message about whether marijuana is harmful, or it's organic, or it's always been around, or parents may have used it when they were young and we turned out okay. But the idea here is to focus on today's youth, who are living in a very different world than the parents who lived in the 60s and the 70s and the 80s. The marijuana is different. There are some people that may disagree with that, but lo and behold, there is a purer product that's being synthesized in ways that we don't know what it's going to do to the brain. We do know that one thing that's not going to change is that kids are not going to have a decrease in stress. We know that kids are not going to not feel anxious. They're going to feel all of these things. And so this increase in substances kind of reflects that. And part of it is how they're perceiving things as harmful. And so it's important to provide education about how the brain develops. That's why I spent so much time on that part of the topic. But importantly, there's also a lot of other statistics. Like kids who use marijuana also have a tendency to also have a lot of depression, a lot of anxiety. And so it's hard to know which came first, the chicken or the egg. Were they depressed and they felt like they wanted to use substances, or were they anxious, or did that cause the depression? I'm not here to say anything is causal. I'm here to say that these things are related. But we also know that there is an increase in the prevalence of kids who use substances and experience some mental health issues. And so part of that too, kids have kind of gotten the message. So typically, most of my work is around adolescent alcohol use. And so marijuana use is increasingly more prevalent. We know that there's also a difference in the perception of harm. So kids know that binge drinking is dangerous. And accordingly, there's been really a decrease in how much kids use. On the other hand, though, there's actually been a decrease in how harmful kids think marijuana is. So I think we have a lot of work to do, and there's a lot of research that needs to be done, but hopefully we can understand this. So now that you've all been exposed to what fMRI or brain imaging looks like, I'll just show you a few of the more recent things that have been published. There was a really classic study that came out of the Netherlands looking at over 1,000 individuals. They looked at kids who started using cannabis when they were 13, and they studied them at 18, 21, 26, 32, 38. There are people who love this study because they think it makes an important point. There are people who really complain about this study because they think it wasn't appropriately controlled. In general, the summary or the takeaway is that there's an association between early onset use and a drop in IQ. So in this particular study, there was about an average drop of about 8 IQ points. If there was an early onset, if there was use prior to age 18. If they waited until their brain was adult, you didn't see the same decline. In a smaller study looking at 40 adolescents over the course of, they stopped using and they looked at abstinence, all of these domains were affected. So they had worse attention, they had worse learning, they had worse working memory. And so are these clinically significant differences? No, they just were different than kids who didn't use. And again, there's a whole host of other factors there that could play into that. But, if these are the abilities that we really want to make sure that are working well in kids, I think that anything that we can do to help encourage that process is important. You remember the Stroop Test, you all did this. If you look in teens who are non-users, you see this very efficient use of the frontal lobe to perform this task. If you look in teens who are marijuana users, and it's important to say that these are not marijuana users who were intoxicated when they actually performed this. These are kids who use recreationally. They're not, substance abuse kids, but essentially what you see is 1, 2, 3, 4, 5, 6, 7 areas of the brain activating compared to just the 2 in kids who don't use. So what does that mean? Again, this could be a chicken or the egg, but let's just say that in teens who use marijuana, they have to recruit more of the resources of their brain to perform at the same level. And I like to think about it this way. Imagine you have 2 teenagers getting ready to run a 50-meter dash. Only one of the teenagers has on a backpack of bricks. Would it take significantly more effort to get from here to the end? Sure. Could you do that? Of course. We're very resilient. Could you do it? Could you run a mile? Could you run a marathon? And so we think about the things that we're loading onto our brains when it's trying to do all this important development. And what we know is that it's going to affect our efficiency. And so again, if we want to kind of extend the period of how well we can keep our brains healthy, this is a very important thing to think about. So we also know that marijuana has a significant impact on memory. This is undisputed. If you give someone marijuana and you test their memory, the majority of people will show that their memory is impacted. In this particular experiment, when someone's in the MRI scanner, the task is that you have to remember when these symbols are in the same location. So it flashes this one to you, and this one to you, and this one to you, and this one to you. You're supposed to press a button when you see one that shows up in the same place. This is how we hold things in the clipboard of our minds.
But you're saying it affects the memory when they're doing it.
So these are, again, kids who are not using marijuana at the time of the test. These are kids who are marijuana users. And so essentially what you see is that if we ask the brain to light up, so if I show you a picture of something, and 5 minutes later I show you other pictures, I want you to press a button when you saw the one I already showed you. And so I like to think of that, as I said, holding something in the clipboard of your mind. Thank goodness we have smartphones because they do most of the remembering for us. But the idea here is that if you look during the memory test itself, this blue part is how much less of the brain is activated in kids who use marijuana. So it's underactivating when it should be activating. But all these other splotches that you're seeing is now when you are at rest, you're not doing anything. Now the brain of kids who use marijuana is actually overactivated. So there's a mismatch. You're supposed to call the resources and use them when you're being tasked with something, and when you're at rest, you're supposed to recover. But you're not really seeing that. And so this is just one example of a study, but there's also some really interesting work that's come out recently. This was just published in December. And what this tells you is that this part of the brain here, this is the frontal lobe as you know it, there are other parts of the brain called the reward center, and they work together. So when we find something rewarding, our frontal lobe says, oh, I find that rewarding. The part of your brain that feels the reward goes on and says, well, I want more of that, so I'm going to motivate my frontal lobe to go get it. And so what we find here is that in youth who are escalating their marijuana use, so they started off just using a little bit, they might not use consistently, but they're using marijuana, what they find is that how the frontal lobe talks to the reward center gets disrupted. So the things that they found were rewarding, so maybe hanging out with a family member was rewarding, or maybe a single chocolate chip cookie was rewarding, no longer rewarding. So it kind of changes our reward sensitivity. I mean, a lot of times we get bored with things. And, there's some interesting work done about boredom in teenagers. We get bored for good reason, because you're supposed to go find new things to do. In this context, this means that use of marijuana actually changes your reward system, and it can actually dull how rewarding things you find to be. And so, here's an example of all of these brain regions that are lit up. There's not a lot of work out there that's done in kids. I mean, this work is being done now. We're starting to understand kids who use today's marijuana, the impact that it has on the brain. And essentially, we could see there's evidence across a number of studies that a lot of different parts of the brain are impacted. It's not just the frontal lobe. It's not just the reward center. There's a lot of the brain that's impacted. And it does not matter if you take a neuron and you put it in a dish and you expose it to alcohol or marijuana or some other substance, it is going to change how that cell functions. It does not discriminate over age or whether it's a girl or a boy neuron. The fact is that cells work in a particular way. Substances affect that process. Whether it's a positive or a negative effect, that's not what I'm saying. It just affects it. That's just the bottom line. And then finally, a study that came out looked at a chemical in the brain that's linked to depression. And essentially what it found, again, I want to be very mindful of making sure that you don't hear me saying that this caused that. But what we know is that in teens who used marijuana, they had significantly less of this very important neurochemical in their frontal lobe, which is implicated in depression. So if you look in adults with depression, adults who use marijuana, adults with anxiety disorders, they have a lower amount of this chemical in their frontal lobe. And so we also see that in kids in and of themselves, even if they're not substance users, have less of this neurochemical than adults do. That's what's developing. But in this context, we know that it's dramatically lower in kids who use marijuana. So where's the science headed? I know I've handed you a whole lot of information. For your lucky evening is that this is being broadcast throughout Arlington, so you could watch it over and over again. There's also a handout in the back of the room that kind of talks a little bit about some of the brain development work that we've been doing. But where is the science headed? Because there is a lot to do. Now, one thing that's complicated is that we cannot administer marijuana to human youth. It's unethical. We are not going to do anything to kids that would harm this really important process. So, the other piece is that marijuana is different. There are different strains. There are different potencies. It's significantly more potent than it was years ago. So it's not the marijuana of the 60s and the 70s. It's also taken in very different ways. Edibles obviously is a very important concern because you could walk along, pop a gummy bear in your mouth, and have 4 times the potency of marijuana that an adult may have used when they were younger. Why is that important? Because the other piece with edibles is that it takes time to hit the system. You actually have to put it through digestion, which means you don't feel the effects right away. So kids take it, they're like, I don't feel anything. Take another one. And then next thing you know. Now, a lot of people say, yes, but marijuana is not addictive. There is no evidence that anybody has ever died from a marijuana overdose. However, it makes people very uncomfortable. It induces anxiety. It induces a whole number of cardiovascular events. Again, that's not everybody. Some people are more sensitive, some people are less sensitive. We do know that there is evidence that people can become addicted to the substance in a sense that they crave it, they can't go without it, they get grumpy, they want more of it. And so there's a lot to learn. My job here was not to overstate the pro or con, but to provide education that we need to protect the teenage brain. And encouraging them not to use marijuana while they're teenagers is an important part of what we want to pass on. Now, where is the study headed? The important thing to know here is that there's something we used to always think that our genes were fixed. You're born with what you have and it's never going to change. That's not actually true. There's evidence that our genes can change. They can undergo epigenetic changes, and essentially what that means is that they can be modified. And what they found is if you take an adolescent animal and you expose it to the psychoactive property of marijuana, THC, it actually changes the genes, and this transcends generations. So if the grandparents were exposed to THC as adolescents, that actually can get passed down generation to generation to generation. And so what does that really mean? That means parental exposure can actually impact that. And one of the things that's coming out more recently is that exposure in teenagers to THC actually can change how rewarding they find other substances. So it will alter their response to, say, opioid drugs or other types of things. So it's important to know that all of these things kind of fit together in very important ways. And our job is to really take advantage of the science and to become educated. So, how do we pay attention to all of these things that are coming up in the news every day? And who's pushing what agenda? The thing that we could say, there are people, experts. This is the director of NIDA. There are all sorts of articles that have come out. I really want to end on this note. The research on teen marijuana use is close to unanimous in at least one sense. One sense is that more frequent marijuana use appears to correlate with various detrimental effects, including worse education outcomes and cognitive deficiencies. Not for everybody. Important point, these are correlations. We have yet to prove that this causes that. But if we know that there's a relationship to it, it would be good to be able to understand the things that can promote the process as well. So, second decade of life, period of opportunities and vulnerabilities. These are the takeaways from my piece of the evening. Very rapid brain development in a short period of time during the second decade of life. The biggest leaps in cognition occur between ages 10 and 18. And these brain changes really extend into the 20s. This is a time when emotions are strong and can be hard to navigate and manage. And of course, the teen brain is more vulnerable to marijuana effects than the adult brain. And really, the earlier the first use has the biggest impact. One important thing to know is if you take a teenager and they're exposed to marijuana, or if you take an adult, those effects last about 30 days. It stays in the system for about 30 days' time, and you kind of get again, not to say this is for everybody, but for a majority of the people that take it, it takes about 30 days to get out of their system and recover back to the way before marijuana was used. In teenagers, it takes twice as long, 60 days, to recover back to the way it was. So there's a lot to do. There's a lot of uncertainties. There's a lot of evidence, and hopefully we will continue to have these conversations. And so with that, I know that we're going to go to a panel, so we'll take questions as we get up to the panel. I want to just acknowledge my lab and thank everybody for their attention.
Okay. I think we're just going to pull it in the middle. You can't be pulling. No, you did great. How are we doing there? Okay, so now we're going to open up to have some questions. I'll have the panel introduce themselves. I did want to mention, I think most of you noticed, but we have an information table in the back, so please feel free to take some literature. And moving ahead, should you ever have questions or concerns, you can always call me at my office, and I'm happy to help you, because that's what we're here to do. Do you guys have chairs up there? Thanks, Cindy. All right. So I'm going to ask the panelists to introduce themselves and maybe their affiliation to the coalition or in town, or we'll start with you, Pat. Who are you?
My name is Pat Egan. I'm a family doctor, and I work at MIT Medical, which is the medical facility at MIT. I'm not a professor. I'm a primary care doctor, and I'm the associate director for primary care at MIT. I've worked for a long time in community health centers and other places where this kind of issue is a much greater concern. However, even in a college as prestigious and fancy and expensive as MIT, drug use is a big issue, and so I've been paying a lot of attention.
Oh, speak into your microphone.
I'm sorry. So, I can go through that again.
I don't think it's on.
I'm a family doctor, and I work at MIT.
And one of the great things about Pat is a member of our coalition, so he comes to our coalition meetings, gives us the perspective of a physician, and his daughter comes to the coalition meetings with him. So we have an intergenerational involvement, which is really cool. She's a junior in high school. And then we have Rebecca.
Hi. My name is Rebecca Sopoulos. I'm a therapist with the Arlington Police Department.
Hi everyone, my name is Ivy Schmalzry.
Huh.
Hi everyone, is that better? Okay, there we go. Okay, sure, hello. Go ahead, Rebecca.
Hi again. Can everybody hear me?
Yes.
Okay. Hi, my name is Rebecca Sopoulos. I'm a therapist with the Arlington Police Department, so what that means is I work alongside with the officers doing crisis work in the community and providing outreach to the residents of Arlington. Hi.
Hi again, you all know my name. I'm Ivy Schmalzried. I'm the program manager for Project Here, which is a statewide program bringing substance use prevention education resources to middle schools in Massachusetts. And my previous role, I was the director here in Arlington for the coalition, and I'm happy to be back.
Hi everyone, I'm Erica Golden. I'm a licensed mental health counselor at Arlington Youth Counseling Center. You can primarily find me in the high school, and then also the Hardy Elementary School, and then working with youth, and I do some of the tobacco work for any violations that some of the students are, if they're caught with vaping or any substances in the high school, I work with them as well. And you know me.
And you know Dr. Silveri.
Probably
Okay.
more than you wanted to know.
No, it was great. She was a great. So, does anybody have a question? Okay.
Grant Cook, you mentioned a lot of your presentation was around the clinical long-term Is that too loud or feedback? The clinical impacts of early marijuana use. You didn't really touch on the behavioral where, and maybe there's no studies around it, where early use of a mind-altering drug in the developmental years where there's lots of interactions and challenges of learning and dealing with your peers and your teachers and authority, et cetera. Are there any studies around the kind of the behavioral element of early onset of marijuana cannabis use?
Sure. So, you know, I did skip to the neurobiology a little bit, but if we think about what that kind of reflects, it reflects, you know, impulsiveness or, you know, there's a whole host of behaviors of things that kind of go along not with just cognition, so your ability to have memory and have good, you know, decision making, but the other pieces of things that kind of feed into that. So your ability to interact socially. We know that there are effects on marijuana in terms of, you know, how socially connected you can be to another person, how well you can read someone's, you know, social aspect of things. And, you know, I think this is kind of also affected, of course, by the fact that people have more web presences than they do person-to-person presence. So part of social development is another important piece of this. So we know that's impacted in kids that use marijuana as well.
Great. Thank you. Anybody else? Thank you.
Thank you. If someone says at 14, after they had their first joint, that it was the best they ever felt, what is that? What are components of that statement?
Well, so part of it certainly is the reward system. I mean, when you eat a donut, it feels rewarding, even though you know that it's probably not the best thing for you. If you walk outside and hear the birds singing, that could be rewarding. So one of the things that we know about kids, just in and of themselves, is that their reward system is sensitive in different ways than adults. So one of the questions that we have also is that, you know, why are kids so looking to alter their consciousness in a way that kind of gets to the point that you're making? So there is a part of the brain, there's the dopamine system, that's the neurotransmitter that kind of gets passed along as we experience something rewarding. And once our body feels it, so marijuana can release dopamine in the brain. And once we've released that, our receptors in the brain pick up on that. And then when the drug is no longer present in the system, the brain says, wait a minute, where'd all that good part go? So it's really related to the release of reward compounds in the brain and our brain's reaction to that. And some people, you know, need a dozen donuts, whereas some people only need one. I didn't think I'd talk about donuts this evening, but you get the point, is that people have different thresholds of reward. That could be influenced not only by your biology, but also by your genetics. So if you have people with a history of substance abuse in your family, if there is a genetic predisposition, that can also impact the reward system. So one of the things that we know is that if you look at kids even prior to their onset of use, kids who are family history positive for an addiction in their family, their brains actually respond a little bit differently. So in that Stroop test that you did, you know you have to light up the frontal lobe to perform well. If you look in kids who are family history positive for substance abuse but haven't started using, they actually have to light up more of the frontal lobe to do the same job. Now this is not better or worse. They perform equally well. They just require more resources to do it. And so one of the things that I work with a clinician on the South Shore, Barbara Green, we talk about strategies that kids can use to think about, well, that substance made me feel good. I know that it might not be good for me. She recommended something called the 10-10-10 rule. And that's actually a term borrowed from Susie Orman, who is not a neuroscientist. But essentially it asserts that if kids have to make decisions, wait 10 minutes, wait 10 hours, wait 10 days. The longer you can wait when you have to make an important decision, the longer you give your brain to really make that frontal lobe step in. And so if you think about kids at a party, you know, we talked about what were you thinking? I knew I didn't want to do it, but I did. Well, why did you do it? I don't know. But if you're at the party and you say, wait 10 seconds, in the scheme of life, what is 10 seconds? If I stop talking for 10 seconds, you're going to think something's wrong with me. The idea is that the kids are at the party, someone offers them beer or marijuana, they had an experience with it maybe before, they know they don't want to do it, tell them to wait 10 seconds. I have to just text my mom, I have to do one quick thing, get them out of the situation for a moment so that their frontal lobe can step in and help them make a better decision around that. And that kind of gets to the behavioral piece of things as well. And so not all kids need a 10-10-10 rule. Some kids need a 12-12-12 rule. And so if we're talking about things like family history and genetics and exposure, all of those things kind of come in together, whether they're experiencing anxiety or depression, maybe it alleviated something for them in the moment. There are a lot of people who use marijuana medically to relieve a lot of conditions. It's just there's not really anything known about what that does to the teenage brain. And so that's part of the process of what we're trying to figure out. So that's a great question. And hopefully, even adults use that 10-10-10 rule. I always tell my mentees, never respond to an emotional email on a Friday. Wait 10 seconds, put it aside so you don't have to say, what was I thinking?
And in speaking to your question, I attended a lecture at Lesley University by a gentleman who deals with teen marijuana addiction. He tries to help. I think it was... it's an addiction center. And basically, he was saying his approach to them, he introduces them to yoga and other things because he said he wants to teach them that they're trying to manage something internally with something external. And then what are you going to do when you no longer can access that external thing, or you need more of that external thing? So you're better off developing these internal skills so you have the self-reliance to manage these emotions. So rather than turn to that joint to feel good, maybe do something like go for a run or paint or play an instrument or something that is more accessible to you and is from within. And I thought that was an interesting approach.
That's a good point.
Anybody else? Oh. I'm sorry. The panelists wanted to say something. Did you want to?
Hello? Yes, I want to thank Dr. Silveri for a very elucidating lecture. I think we can all agree that it's probably unwise for young people to use substances of anything. Briefly, people who know me, usually it's that I'm on either town meeting or I was, as the chairman of the Uncle Sam Committee, brought you Uncle Sam Plaza. But most of you don't know that I was the publisher of a well-known drug education program that was used here in Arlington in 1972. These are the marijuana booklets that were being used back then. Now, at that time, I was a good deal younger, of course, but we went from this, which was used in every state of the Union, and later on we developed drug education, including marijuana, for the Army and the Navy and the Smithsonian. And after that, we journaled the Journal of Cannabis Research, which went on for a number of years before we got the patents on the medical marijuana that is used for Epidiolex and Sativex. And shall we say, I'm very happy that now in 2018, since I was been educating people about marijuana since approximately 1970, it's a grand tradition to do this, to try to bridge this gap. Immediately, I think I should answer the question that the first person asked. One of the immediate effects of THC on the brain is the rapid release of norepinephrine, which is a higher brain neurotransmitter. And this happens rather quickly. But the interesting thing is this. Because a lot of norepinephrine is going across, the brain thinks that it's more interesting. It's not. It's really you're just using up more norepinephrine. The other part of it is this norepinephrine surge will result in a surge of adrenaline. You've all heard about adrenaline. Now, this is obviously because if something is funny going up there, really important, you'd better get the adrenaline out. It happens very, very quickly. So to answer the question, the first thing that happens when you take the joint is that things around you appear to be more interesting. Well, it's not really happening. You're just getting a norepinephrine surge. And that gives you an adrenaline surge, which makes you feel good and wonderful. And this goes on for roughly 40 minutes or so, and it begins to wear off. And as adrenaline wears off, you feel sort of laid back and sort of like that, you know. And of course, you're feeling a little dumb too, because you've got to build up more norepinephrine to do it again. And that's why marijuana is effectively self-limiting, because you can't keep doing it. You'll eventually just fall asleep. Now, the real point that I wanted to make is that I'm very, very in favor of the work you're doing in keeping people aware. I know the lab you work with, one of your colleagues, Dr. Harrison Pope, is an old acquaintance of mine, and I have had my brain in your MRI machine. And I would like to add what Dr. Pope has said, and I think with which you agree, in which you did make the point, that when you have chronic marijuana use, especially in younger people, you have possibility of three possible situations. First, there may be an underlying mental problem that is causing this person to use marijuana more than the average. And this is something which, as a parent, you're supposed to be sensitive. Does my kid have problems? And this is one of them, and it leads them to use the marijuana, and this is what leads to the deficits later on. The second, which you also made a reference to, was the fact that people who use a lot of marijuana often don't study very much. They don't stay in school very often, and they're sort of leaving out a very important part of their life. And that's another reason. Then there's a third possibility that there is a neurotoxic connection between the cannabinoids, all 87 of the cannabinol, cannabisol, cannabichromine, and all the other cannabinoids that may, in fact, have some direct effect on parts of the brain. But as you pointed out so well, this is a correlation. There has never been a direct connection. The jury is out on that one. So I think we can say it's good to keep aware of the fact that these things are happening, that neurological experimentation is increasing, that young people should not, under any circumstances, get themselves involved with drugs. I have to admit, and I don't know if I should even mention this, but I have to admit that when I was 19 years old, I tried marijuana myself.
In the sake of time, I want to be able to allow other people time.
Yeah, there's a gentleman on the side here. That
Okay, but I want to add that I never stopped. I'm 73 years old. This is what 50 years of use will lead you to. A couple of books, a couple of corporations, and reasonably good health.
Thank you for your comments.
Yes, I'll bring it around. Thank you very much. Sorry, didn't mean to. We're just limited on time, and we want people with children to be able to get home and do their homework. Thank you.
Thank you. That was a very interesting presentation. One of the challenges that we have is that you demonstrated a link between marijuana use and certain parts of the brain which light up with the different imaging techniques that you use. And another correlation between a part of a brain and some observed trait. Either it's a behavior or some kind of outcome. But these are correlations. And as you said, that the causality has not been established. When you're talking to a teenager and trying to tell them, don't smoke pot, or you will have, something will happen, whatever that is. Just as you have that information that it's a correlation and not a causality, they have that same information. So how do you deal with that? Because they'll just turn right around and say, no, it's not been proven.
So,
you understand the question?
I do.
Okay, thank you.
I do, and my children will be teenagers one day. So my first answer, and I appreciate the point, and I only make that such an important point because a lot of people say, well, it's never really been proven. And in science, we don't really prove things. We find supporting evidence. There are many animal studies that have shown that if you expose an animal to THC, now animals are animals, not humans, we can't do, they're starting to do some of that research now. But if there's a greater likelihood that someone won't do as well in school, a greater likelihood that they will make worse decisions, a greater likelihood of depression or anxiety, I think that's still relevant because there are a whole host of things that we don't even know that are occurring in our body or brains that may be related, that maybe we'll figure out or not. But I think that it's kind of undisputed that there are strong relationships, strong predictive nature that using, so one of the, going back to the point about the behavior, even to the sense that, well, maybe it doesn't directly do each of those elements in every single person the same way, it also deters you from paying attention or to, it takes 4 hours out of your day that could have been spent somewhere else. I think focusing on the idea that it increases risk in so many dramatic ways in kind of understanding the statistics around that is still useful. Because, again, there are things that we can only measure in certain ways, and until there's no direct way we would ever know this in kids because we're not going to take that chance. But now there are a lot of adult studies where people are being administered THC in known amounts, and so that information will also be important. Because the other thing we don't know is we don't know how much increased potency or, availability of increased use in adults. We don't know what that's going to do to the adult brain either. And so, do I have the perfect answer for you that no, I don't have the exact facts, but there are a lot of studies that have very convincing evidence that using marijuana as a teenager can derail the process of brain development. It can impair your memory to the extent that you perform 10 to 20% worse on tests of memory. Again, not for everybody, but for a large proportion of people. And there are a lot of statistics available that can support that. And I think, whether kids see the brain images I mean, you've not seen that image before of someone doing the Stroop test. You see that it takes a lot more brain. And if we think about it from the perspective of kids, they want to do well, they want to be successful. And so they want to get good grades. And that's really an important part of this conversation. The chances of you doing better on your tests will increase if you don't expose your brain to something that's got to work against. Because exposure to any substance for the teenage brain means that it's going to take resources away from what it's supposed to be doing and instead focusing on something else, which is trying to remove the situation from your brain. And there's also a chance that there could be a problem. 9 to 30% of kids who use marijuana before 18 go on to have an addiction later in life. And I talk to a lot of kids. It's difficult to explain to a kid who doesn't have an addiction what it means to become addicted. So it's something that happens that we almost don't even know is happening until it's happened. And so that is a difficult concept. And for this panel of people who are experts in this realm, that's one of the other pieces, that risk of addiction sounds nebulous, but it's a risk. And so, does anybody else want to comment?
In fact, I have teenagers, and so we have this very discussion. The way that I frame it in my own head when I'm just talking to my kids is marijuana, alcohol, pick a substance. Any of them will fit into this framework. As Dr. Silveri said, each kid is going to respond differently. But there's a real strong risk, and some of these are better proven than others, but there's nothing that we can say 100%. You do this, take this substance, do whatever, that you're going to get this result. The variety of kids, the variety of brains, the stages of growth, all of those factors are a huge part of this. But the way that I've thought about it and talked about it with my kids is we have, an opportunity to either do something that's potentially harmful or an opportunity to do something where you're not exposing yourself to that harm. There's enough, mishigas in the world right now that adding something like that to the developing brain, again, we're not talking about what happens as an adult, as a sort of 25 and over adult even, because in the same way that you can't rent a car till you're 25, the capitalists know when the brain is getting developed. That window of kids in their teens particularly, heaven help us when the kid turns 21 and is officially an adult. We're really not in charge anymore, but we are, to a pretty fair extent, in charge is the wrong word, but we're going to have a huge influence on our kids' behavior. The rhetorical pieces that are going to happen between parent and child are rhetorical in that way. Kids really do know that, they probably know some of this data better than we do. And, I'm someone who works in this field. That is both true and at some level irrelevant. The kid also knows, despite the argument, that, there's a risk I'm taking with this sort of potentially harmful substance, whether it's alcohol or marijuana or, pick your host of other substances. Kids kind of know that. And that kind of discussion with, you're taking a chance. How do you want to manage this chance you're taking? At least that's how we framed it in our house, and that's how I talk about it with my patients. I take care of a bunch of college kids and some teenagers, younger teens as well. Those are the kinds of discussions we have there. It is, of course, not 100% anything, but hopefully kids will make better decisions when they're given a framework in which they can make those decisions.
Did you want to say?
Yeah, I think also some of the things that I talk to the high school students about is, what do you have to lose? So they're not necessarily going to look at the science. Some of them are. Some of them spew the scientific facts to me and my head spins and I'm like, wow. And then others don't care. And I think that more often they don't necessarily care, or they don't want to hear it because I'm their therapist, you're their parent. They don't want me to give them facts. So what do you have to lose? You're driving in the car. Your car smells like marijuana. You get pulled over. Are you going to be driving ever again? Probably not. You choose to go out with your friends, you smoke, you drink, you go to a party. Are you going to do well on your test tomorrow? Are your parents going to be mad at you? Probably. So what do you have to lose? You can even go as far as, if you choose to start smoking marijuana throughout all of high school career, are you going to graduate with the grades you want? Are you going to get into that good college? You kind of have to set it up like that. What are your goals? And do you want to reach those goals? And oftentimes I have kids start to actually talk about that with me, formulate that with me. You're right, I am going to lose something. I'm not going to reach that goal that I've had since I was, 5 years old. Some kids, I want to be a dancer, I want to be a baseball player, I want to be a football player, that kind of thing. So sometimes that's how I frame it to the teens that I talk to.
Thank you. I have a question from.
Sorry, jumping
Sure,
on this
that's
piggyback
okay.
wagon. So I just want to kind of also just say, at the end of the day, unfortunately, teenagers are going to do what they want. And I think the only way to actually engage in a conversation with the people that you're raising, with the people that you're working with, is being honest and doing it in a collaborative way, meeting them where they're at. That's, therapy 101 is meet your client where you're at, especially for parents. You lecturing just because you're right doesn't mean that they're going to hear you. I really would suggest having an open discussion with your kids about what they're actually trying to do, what they want to do. The marijuana laws are changing. Again, I can talk your ears off about that. I literally brought all my different case law because it changes every 5 days at the moment. At the end of the day, though, marijuana does have consequences. Children aren't always going to listen to those consequences. What's important is having a conversation about what's going on in the moment and having enough trust so that if they're ever concerned or at risk, they feel comfortable enough to call you and get themselves out of that situation. Because the worst thing that we can do is to stigmatize it so much that these children are fearful of our reaction and they end up doing something much worse than smoking a joint, right? Because I hate to break it to you, I'd say about 90% of our kids at some point are going to smoke some weed, but if they're so scared about what is going on, they're not going to be able to reach out for help when they actually need it. So really coming at them with a place of compassion and trust and understanding and figuring it out together in a collaborative way, I really think is a really important way to move forward.
Making sure consequences are known, but not necessarily the only option.
Okay, thank you. I have a question from a young person.
What makes young teens start using drugs and marijuana?
Did you ask when?
She asked what?
What do they start using?
What makes teens
What makes them?
What makes them start using?
Well, I think part of it is, as I said, there's a part of our brains that when we're young really wants us to seek out novel things. It sounds interesting. One of the things that most of the kids actually won't go on to use marijuana or alcohol. There's significantly less kids that will use it, but there's also something called social norms where people have the idea that everybody's doing it. And in fact, actually a lot less people are doing it than you think. So it's one that you feel like you want to do what everybody else is doing, even that's not the reality of what happens. Kids seek out things that are going to change their consciousness because that's part of the development of the brain and understanding how we work. For some kids, they might be drawn to use it because it might help improve their sadness or their anxiety. In most circumstances, it actually makes those things worse. And so part of it is just investigating the world. And I think that's one of the important points to take away tonight is that teens or adolescents have always been drawn to doing things that are novel and to, again, get out of the nest. The difference is that today in 2018, there are a lot of risks and there are a lot of harms. And some of those things include substances. So I think it's intriguing, but I think with enough education to really understand what it does, I think that will help people be able to make better decisions. Thank you for your question.
It was a good question, and I feel like it's great you're here because all this information you're receiving, if you find yourself in a position where you have an opportunity to use marijuana, do you feel like now you know a little bit more where you feel like you can make a choice that's right for you? Yeah, that's the goal, which is great. So thank you. I'm glad you asked that question.
Join
Did you have
OCAP.
You talked about how anxiety and depression is sort of in this whole mix. How do you deal with teens who actually say that it relieves the anxiety and so that's why we would use, and not more from the risk aspect but more from relieving the anxiety? So, any of you, if you could respond to that.
So is the question why they want to use to relieve those
No,
symptoms?
how do you approach a teen who is using that as the reason for use?
Sure. Well, yes. They think it makes them feel better. Full disclosure, I'm not a clinician, so I don't see patients, but if somebody else wanted to comment on that. But the idea really is that people want to alter their consciousness because they think it will help them feel better in some way. And so, I love that Karen brought up the idea of things like yoga and other types of things that can actually improve mood, reduce anxiety in a way that's naturalistic as well. So I don't know if you wanted to...
I think that I hear that all the time. Okay, so I say, for how long? 5 minutes, 10 minutes? How do you feel an hour later? How do you feel when you walk into that math test and maybe you haven't smoked any marijuana? Does it really actually reduce your anxiety? I think that the argument that they make all the time is, well, I feel calmer. Okay, well, how did you feel when maybe you ran that mile or something? Because unfortunately, some of the students that I work with happen to be athletes. How did you feel when you ran that mile? Well, I felt really good. Okay, so you didn't feel anxious, right? So they're like speaking to the yoga piece. There's other ways to use it, and I don't necessarily know the science to this entirely, but I do know that some of the studies that I've read, that actually there's a mix of, with some people that anxiety actually increases, and I see a lot of my students actually really feel their heart pounding harder and getting a lot more anxious. And then also it kind of, I don't know the correlation, but I know that it also can affect the depression. So maybe your anxiety reduces, but then your depression increases.
I think in the name of time and to respect your schedules, we'll have one last question, and I wanted to just speak to your question, which I think is great. As a teenager, I had issues with anxiety, and I know that feeling of powerlessness, which is what anxiety feels like, at least to me, that there was nothing I could do, this would come out of the blue and overwhelm me. And if you, again, choose to medicate, you think that is the magic bullet, and that's what's healing your anxiety. Whereas if you develop an internal resiliency skill, you're going to be better suited as an adult. That's just my personal feeling.
Hi. I am a firm believer also in doing something other than substance abuse for adolescents, like yoga or jogging or biking or sports. Right. What if you have someone who said, and you suggest all those things to relieve anxiety or depression or whatever, and the person says, oh, yoga or biking or whatever, that's not my thing. I personally find that a very difficult statement to respond to. So how would you respond to that?
I'll answer that because I was probably one of those kids. I did not like doing yoga. I have 2 left feet, so I could not dance. I played field hockey, but I rode the bench most of the time in high school. That being said, I really loved hanging out with my friends. We would go to the movies. We would play mini golf. We would watch Disney movies. I don't know. So I think my easy answer is that it doesn't have to be an organized activity. You can just do something else, something that's fun. And try to do it with friends, because it's if you're lonely, that's not going to be fun. Even book clubs, if you get a group of people together and you want to do that. So it's totally fine if it's not the thing, because it wasn't mine, and yet I have never used marijuana, so.
And I think that also, just to answer the question, I'll say to the student, well, what do you like to do?
Right.
What is it? And it's not the first, second, the third session sometimes, right? What I try not to do is make recommendations. I'll say yoga, I try meditation, I try it in session with them. At this point, I think most of the students in the high school at least know me well enough to know that, okay, Erica's probably going to make you try to do something that maybe you don't want to do, but they're going to do it because we've built a rapport. But I try not to suggest. I really try to help them come up with something, and actually eventually they do. And then I say, okay, let's try and test this out at home, and let's see if this works. And it's not always going to work, but they try. So.
And if I could add one last piece into this, one other thought or suggestion is there are ways that are very effective to modify people's behavior. So things like cognitive behavioral therapy that teach a skill set where you can kind of identify what's making me think this, and how does that influence my behavior, and how does that work together with my, my feelings around that. And so CBT is especially, for people who like to think in their, internally thinking, that is a great strategy to be able to have a skill set, to be able to say, oh, I'm having that thought. Instead of going to a substance or doing something else to change that, how can I just understand my feelings around it in the first place and kind of learn ways to modify one's own behavior? It's a very strong technique, especially for kids, especially around anxiety and trying to understand what this triad is in terms of how you're feeling and how you're thinking and how you're, reacting.
Name is Grant. I wanted to add just one thing about addiction and the progression as you move toward it, along it actually. And as a parent, one of the hallmarks of the progression deeper into substance abuse is isolation. Isolating from friends, isolating from activities, isolating from, you want to hide the addiction, you want to deny it, and one of those is cutting off connections. So if you see that behavior, I mean, that's where, ask for help as a parent. There's a point where if a person is in the progression, you have to have them admit the problem is developing. You can't force it on them, you can't, and that's where very well-trained people like therapists come in. But isolation is a big danger sign. If you see it, I would be very cognizant of the possibility that they're moving down the path. So, thank you.
I want to make one plug for resources. Sure. Is that okay? Just to have.
I have an anonymous question that I got at the office. Do you want to? Yeah,
go ahead.
Okay. So this is a little sensitive. This is a question about physical relationships. Does marijuana use hinder a physical relationship if a young person chooses to have a physical relationship with another person? In particular, if that user is a male. I'm trying to address this.
I'll jump in with this one. The short answer is yes, or potentially yes.
Okay.
Again, everybody is different, but this can totally happen.
Well?
This is partly, it's actually not a physiologic effect, or at least not a direct physiologic effect. You don't suddenly become impotent when you smoke a joint. But as Dr. Ruth Westheimer used to say, the most important sexual organ is your brain. When the brain is not functioning normally, the downstream effects are that not everything else is going to function normally. So that's a completely plausible sort of thing. Okay. I see it occasionally with the students that I see who are sort of freaked out at this. And it's almost always a situational thing, or in this case, a substance thing, or maybe both of them. But both of those sort of issues, the situation, the substance, can have a huge effect on sexual performance. Let alone the question about how well can someone consent to sex if they are not 100% with it. There's a totally other question to address in that. But yeah, it's occasional, but it's real.
Okay, thank you. And thanks for tolerating a sensitive topic. Ivy, you wanted to make a plug and then we'll wrap up?
I was just going to say that there's a few really great resources out there for parents. One of them, I'm staring at them on the back table. It's the Marijuana Talk Kit. It's from an organization called the Partnership for Drug-Free Kids. And in it, they actually have scenarios where, if a child says X, this is what a parent could say. And so it gives really good examples of how to have these conversations. The other one is a resource online called Speak Now Colorado. Google it, Speak Now Colorado, and it comes out of the Colorado Department of Public Health. We know that marijuana has been legal there for a while now, and so there's a lot of good prevention efforts going on in that state to prevent youth use of marijuana. So I just wanted to point out those two educational resources that we are trying to promote across the state of Massachusetts.
Thank you. And the coalition is here for you. We have lots of resources, so thanks for coming out tonight. And if you need to have more conversations, let us know. Thank you.
Thank you.
Good night.